concept of design thinking approach in mathematics. So in this semester we have two things major. One is integral calculus, the other one is differential calculus. So what is the primary importance of integral calculus and differential calculus when it comes to engineering? For example, if you take any industry, you can take any industry. If there is a R&D department, 100% they will be using integral calculus and differential calculus. The reason behind is, suppose if it is a manufacturing company, okay, they will be interested to discuss certain things towards area. For example, finding an area of a square or a rectangle or a triangle is very easy. We have a standard formula: right angle triangle, scalar triangle, equilateral triangle. For each and everything we have a formula. So what about irregular surfaces, irregular regions? So in order to find the area of irregular regions, we need some parameters, we need some formula to solve it. So in that case, we come across the concept of integral calculus. Maybe in school level, you would have read that the area is equal to integral a to b by dx kind of formula you might be used. So with this, you will have some limit. Maybe if you are going to discuss along x-axis, the limit will be along x-axis, so 0 to a in that range. So what is the area covered? So maybe if you want to find an irregular, for example, you can see the survey department. Survey department, they want to calculate. If we are standing here, next to a river, there is another place. So from here you have to calculate. It cannot be exact, but at an approximate value, you can calculate what might be the area of it, because it's hard to travel over there and it's hard to measure those things. So in order to measure, which is not exactly in a perfect shape, so we use the concept of integral calculus. And again, when it comes to volume, so we can find the volume of a structure by using integral calculus. So very important two things in integral calculus is, one is to find area, the other one is to find volume. In our syllabus, we are going to find these two. So how to find area of a given situation and what is the volume of a given situation. So the question will carry the limits. So some boundary conditions will be there, because we need some boundary conditions. We need the equation of this curve. So by knowing the equation of this curve and by knowing the range, you can find the area. Similarly, if you know the equation of this particular, maybe it's a cylinder, maybe the cylinder might have some other extra inputs into this. So if you know the equation of the cylinder along with the dimensions, we can find the volume of the cylinder or whatever may be the structure. So it is connected with mensuration. So what is the exact difference between integral calculus and differential calculus? Differential calculus talks about rate of change. Suppose if you are climbing a slope, so in each and every space gap, so what is the distance you have covered, maybe with respect to time. Maybe if I say this is distance and this is time, what is the rate of change of, maybe if I am standing here, what is my rate of movement with respect to time? By each and every second, what is my movement? What is the rate of change? This you can connect with your mechanical engineering, maybe heat and mass transfer, maybe thermodynamics, maybe fluid analysis, maybe the flow of fluid, maybe from outside areas, from through pipelines, crude oils are brought to our country. So how is the flow? So whether the flow is happening properly. So what is the rate of change of flow with respect to time? So what quantity of amount is getting transferred? Like this, in many areas where there is rate of change, we use the concept of differential calculus. And also these fundamental things you have known. Velocity, you are using the concept known as velocity related to force, and next level of velocity is acceleration. Again, to find velocity is nothing but rate of change of displacement. How do you find acceleration? Rate of change of velocity. In mathematical terms, we call it a second derivative. d square y by dx square is nothing but acceleration. dy by dx is nothing but velocity. Third level, we talk about d cube y by dx cube. When you connect with the real-time problem of maybe physics or mechanical engineering or wherever the force is involved, you can come across jerks or vibrations. Okay, to the next level, see, so you are giving a velocity, to the next level it is moving to the term called acceleration. Again, the force, if it is getting increased, you go into the concept called jerks or vibrations. You know, if you travel in a bike, if it goes more than 100 km speed, obviously you get some vibrations based on the capacity of the engine. Alright. So likewise, so these are differential calculus. Whenever it is concerned, it is talking about rate of change of a parameter with respect to other one. Rate of change of displacement with respect to time. Rate of change of velocity with respect to time is acceleration. Rate of change of displacement with respect to time is velocity. Likewise, with respect to one variable, there will be change in the other variable. So that is how this differential calculus works. But when it comes to integral calculus, it talks about integrating the system. So where we talk about the volume concepts and area concepts. So fundamentally, at this situation, in this semester, we are trying to discuss.